Okay, so let's have a look at that naive example I talked about, this bankomat ATM system. So let's consider no one has done this before, and you're those people back in the 1960s who the bank comes in, the manager comes in and says, guys, I want you to make machines that can withdraw and deposit, allow customers to withdraw and deposit money without having a physical human presence. I think I want to call them ATM machines. So you're there, you're in this bank, the bank manager, the owner of the bank, or the CTO, the CEO of the bank says, build me this computer system, this system that allows customers to withdraw and deposit money into their accounts through an automated machine. So off you go, it's like, okay, so here's our big server, and in those days, remember, the central bank server was sort of probably a mainframe computer, not what we see nowadays. It was a single big machine. These things down here would be very simple machines. We didn't have, 1968 is pre-microcomputers, pre-PCs. 1968 was mainframes and terminals. So anyway, we won't go back that far. Let's keep it real, as in modern. So you go, okay, so here's all of our servers over there in the cloud. So we've got to create these ATMs. It's going to be a computer, each ATM, and what we're going to have to do is we're going to have to write a computer that can interact with our servers, okay, and perform operations. So they'll need to authenticate customers, and they need to be able to reliably, essentially, authorize the withdrawal of money, and also to reliably accept the depositing of money. And it's going to be a network because we're going to have multiple of these ATMs in each branch, and they're all going to have to talk to our main servers here in the head office. So off you go, and they come up and say, okay, here is a potential solution. So let's ignore the authentication bit. We'll worry about that later. Let's say somehow we have something that allows the customer to authenticate themselves. Maybe it could be a card or something, I don't know. Okay, so the customer again gets the script, says, okay, do you want to deposit money or do you want to withdraw money? Let's focus on the withdrawing bit. So the customer hits withdraw, and then we enter an amount. They choose an amount, and then they press go. When they press go, the ATM needs to talk to the server to ask it, can I do this? Can I give the customer the amount of money that they've asked for? So we're going to have to send a message of some sort. It's got the customer ID, so we know who we're talking about, the operation, which is going to be withdraw, and the amount. The bank server is going to receive that message, and then it's going to either say, okay, yeah, you can give them that money, they have the money in the account, or sorry, no, don't have the money, so I refuse to give you, I refuse you permission to give them the money. If the okay is returned, then the customer gets the money. If refused is returned, the customer gets some random error message that kind of tries to indicate that you don't have enough money in your account, but doesn't actually say you don't have enough money in your account. On the server side of this solution, the server is just going to sit there waiting for messages from ATMs. When it receives a message, it's going to check it's going to use the customer ID to check the user's account, the customer's account. It's going to check whether the customer has that certain amount of money in the account, and if they do, it's going to send it okay. If they don't, it's going to send refused. Pretty simple, hey? This is pretty cool. Basically, just summarize, I type into the ATM, I type in the amount of money, I hit go. The ATM says, can I give them this much money? Can I give this customer this much money? The bank goes, yes, I get my money. What could go wrong with this? Here's a diagram of that solution. What could go wrong? Well, what happens if I type in the money, I send my request to the ATM, I enter my request in the ATM sends the withdrawal request to the bank server, the bank does a check and deducts the money from my account, but the server crashes before it sends a message back to the ATM. From the service side of things, it has made the deduction, but the ATM doesn't receive the reply. This means that the ATM will probably time out. That's the solution. But it'll time out and tell the customer, sorry, you can't have any money because I timed out. But when I try to go in a second time and try to withdraw the money when the ATM recovers, I now find out we only have 300 euros. I've lost 200 euros. How do I roll back that transaction? How do I roll back? How does my system detect that this operation didn't complete successfully? The same thing happens if the ATM, the server sends back a response, but the response gets lost. Essentially, it gets lost in the network. It becomes a lost packet. Okay? Or it times out. Or it takes days to arrive. The ATM, as I say, it has to have some sort of timeout mechanism built into it to say, well, if I don't get a response within a certain period of time, then I've got to say, sorry, no, you can't have the money. So, again, the money could have been, the request was sent, the request was processed, the response was sent, so I suppose, but the response was never received. I suppose the difference between these two scenarios is that in the first case, the bank could say, well, it could log the sending of the response. So in this case, if the bank server failed, when it reboots, it can go, okay, so there was a message that was sent here that there was an operation I performed here where I didn't send them, I didn't log the message, the response, therefore undo that transaction. But what happens if the machine crashes between logging of the response and sending the message? There still is, it's decreasing levels of chance of it happening, but there still is a point where that can happen. And finally, what happens if the ATM crashes after the request is sent? So from the service, so the difference is here, the server knows the message wasn't sent, so it can potentially undo it. Here, the server knows that the message was sent, but doesn't know that the message was received. Okay. The similar problems if the ATM crashes, if the ATM crashes, it's sent after it sent the message, it knows the message was sent, the server processes it, but the response is never received. In all these cases, John loses 200 euros or £200, even though John doesn't get the money. How do you handle that? Well, I suppose distributed systems is about understanding how to do that to some extent. Now, trying to build reliable systems like this is not something we're going to cover too much in this course. Okay? What we will do is we will essentially try to understand how to build the distributed system. You need to consider this and these issues when you design your particular solution. Okay? And we'll look at some examples of systems that have been developed where they have proposed solutions to this. Okay, so hopefully now we have a better understanding of what we're talking about. We have an appreciation of the problems that come with building distributed systems. It's a tricky problem because how do you guarantee the behavior? It's easy to describe behavior in the positive case of the behavior, but it's about knowing where the failures can happen and how you can recover from those failures, how you can detect these unexpected errors happening, and how you can make sure that the person who is using your ATM doesn't end up out of pocket at the end of the day.